Cool. So thank you, everyone, for being here tonight. Welcome. Who is here for the first time? Can you raise your hand? Okay, so as usual, like about 50%. Welcome to you. And for the others, if you notice that your neighbor raised their hand, you can go speak to them after the talks, so we can keep including new people. What is WIMLDS? I will say WIMLDS for short because it's a bit long to say Women in Machine Learning and Data Science. And our goal is to promote and support women and gender minority who want to come to our wonderful field that is data science and machine learning, or who want to learn, or who want to discover to maybe one day come to with a conversion or whatever, come to our scientific field. We have a code of conduct. You can read it, but otherwise it's about simple. It's just be nice to others. Don't be mean and don't insult them. Around the world for WIMLDS, it's a global organization, and we are about 100 chapter. Here you are in Paris chapter. And we have like 40 countries covered, so quite big, not only in Europe, in US, but also many chapters in India. A very big chapter in Kenya too. So it's all around the world, not yet. And more than 100,000 members. Sorry, I always mix 100,000, but it's all right. For the Paris chapter, we are 6 co-organizers. We are 4 of us tonight here with Chloe and Jian. If you can say hello, so people can see you. And also we have a great news. We are very happy to share, and we are welcoming Jora. So where are you, Jora?
At the entrance.
At the entrance, yes. So you met her actually. So she cannot be there for her round of applause, but welcome to her, and we are very happy to have her joining our team. Yes, we can still have the round of applause. Yeah, but Jora, she's here. And our second announce for tonight is that we have a partnership now with Le Bon Coin. So welcome to our circle around us. I say this as if we had several partners, but actually you are the first one, so we're very happy about that. And thank you also for hosting us tonight. And I will let you say a couple words about this partnership and what you do at Le Bon Coin.
Yes, for sure. Thank you very much, Marie. Thank you for giving us the opportunity to pitch today. So, hello everyone. My name is Alex. I am part of Le Bon Coin Tech team. And on behalf of the whole team, welcome. And we can make another round of applause. We are glad to welcome you here today. So, Le Bon Coin Tech is the product and tech community who think, build, and run the marketplace of Le Bon Coin. We are a huge community contributors. We host many events like this in our offices. We attend conferences, and time to time we also take the mic on stage to share our learnings. And indeed, as you said, Marie, it's a special day today because we announced our partnership. So 3 reasons why we really wanted to do this partnership with you. First thing is the content. So all the content that is proposed here and curated is high quality. The second is the values. We share common values like diversity, inclusion. And then also the third reason is really the pure community mindset with which you organize this meetup. And we can see that this is the 54th meetup, and this is a huge score. I can tell you that there is a lot of a meetup way behind this. So thank you very much. I wish you to enjoy your conference today. And let me introduce you to Elisa, part of my team and engineering manager at Le Bon Coin.
Thank you, Alex. So I'm Elisa. I'm engineering manager at Le Bon Coin, working in the AI field. I'm also part of the machine learning community at Le Bon Coin. At Le Bon Coin, we are doing machine learning, data science, AI, as you want, since 2015. We even have one of our team members that just won an award in the latest OpenAI hackathon. So congrats to her. But we also know that there is a lot of things that we need to learn. We can learn a lot from other companies, from the community, and we can increase our skills. I don't know how you feel, but when I talk to my team, or even if I think it myself, I feel like there is always a new model, a new techno, something we need to catch up, and that can be, a bit tiring to follow the path, even more with the new Gen AI breakthrough. And I think in that sense, it's really important to have a way to have valuable, trustable, insightful content that are picked editorially. And what is best that having the ability to partner with a community that have a proven track of amazing talks that have succeeded to gather the community on very state-of-the-art topics. So that's why one very first reason. The second reason is like, okay, on the 22 machine learning engineers we have in data science, 8 of them are identify themselves as women. That's not that bad, in fact, for compared to other companies. But that's not really the point. I think, and I think we all believe at Le Bon Coin that gender equality is something that we still need to tackle in this industry. We think that we need to tackle that as a number, but also on stage. And we think that we should earn more, like a very interesting woman that have a lot of things to say. We think that also it's a place where that is still viewed as a men-only area. And so that's another very good reason for us to be very happy to join this partnership. So thank you for that.
Thank you. Well, you can stay. We just have yes, it's working. Just 2 last slides before we can switch to the technical content you came to see. What do we do at Women's BDS Paris? So these kind of events. And also you can follow us on LinkedIn, where we publish once a week on Friday, so tomorrow. We publish a paper that has been at least co-written by a woman. And sometimes we organize slightly different events. Once we organized a sprint to learn how to code in open source. Once also we visited the Museum of Mathematics in Paris. It's great. It's opened only like 2 years ago, and if you haven't seen it yet, I highly recommend it. And that kind of technical event outside. You can connect with us on many usual accounts. And finally, yes, we can start with our agenda. And if Irina, you can come to OpenCV Essential. The floor is yours.
Yeah, that's it. Thank you. Well, I can see it on my screen, but I think we need to wait a little bit before you can see it as well for the more productive presentation. Okay, great. So, good evening, everyone. I'm thrilled to be here today and to present you OpenCV Essentials from basics to small projects. Okay, so my name is Irina. I'm a computer vision engineer with more than 5 years of experience. Firstly, I've been working in e-commerce, developing a virtual try-on solution that allowed users to try different fashion items like bags or garments in the real time as part of the augmented reality experience. And now I'm working in the dental industry at Denti, digitizing crown productions using machine learning and computer vision. Today, my presentation will have 4 different parts. Firstly, I will introduce OpenCV general functionalities. Then we will consider how it can be useful for the data preprocessing, especially in the context of machine learning pipelines. And then I'll share with you 2 exciting ideas of the projects that you can implement yourself to get some hands-on experience with this technology. So let's start. I think you may heard or know about OpenCV, which is an open source library that is available for many programming languages such as Python, C++, or other languages, and it includes many useful functions for image manipulation as well as computer vision algorithms. Let's start with the most basic functions. With this library, you can read images into NumPy arrays. Then you can draw different geometric primitives, such as rectangles, circles, or lines. Finally, you can also add some text on the images and save them. When I was working on the virtual try-on project, I was part of the R&D team, so I did lots of experimentation and debugging, and these very functions were really very useful for me. For example, you can use the draw rectangle function to visualize the bounding box of some that resulted from some detectors, and also when I needed to see the visualization of the pose estimation algorithm. In this case, I would try and draw the skeleton using lines and points from the OpenCV library. And it was fast, it was just perfect for debugging. With this library, you can work not only with images, but with videos as well. Using the video capture, you can open the video and decompose it into a sequence of separate frames. And this comes on very handy if you want to apply separate post-processing to every frame, to every image. And then, as it in the NumPy arrays, you can easily transform it, for example, into a PyTorch tensor and send it to some neural network. Now let's talk about the data preprocessing using OpenCV. Here there are 2 main use cases. Firstly, we may need to preprocess images in case if you want to run inference with some machine learning pipelines that you may know are very sensitive to the format of the input data. For example, it might be sensitive to the size of the input images or to the colors normalization. And in this case, preprocessing is necessary to have to gain very good results. And the second and also very important use case is image preprocessing if we implement the augmentations that is necessary to avoid overfitting on our training dataset. And today, I will give some more examples of the OpenCV functions based on this context of developing augmentations for the images. So the first type of the image augmentations that we are interested in are geometric transformations. For example, these are rotations, translation, or scaling of the image. We just need to write them in the format of the matrix and pass this to the corresponding function. Also, we may want to adjust the color settings of the images. For example, with OpenCV library, we can easily switch between color spaces or adjust brightness. We may also want to implement some image blurring or sharpening, as well as add some occluding or masking using other geometric primitives. And this will be especially useful, for example, if you are training an image in painting network. Before I switch to the next part of my presentation, where I share the ideas for the projects that you can do, let's discuss why do a side project. So firstly, it's one of the best ways to gain some hands-on experience with the new technology. Because when you actively practice everything, it helps you to get knowledge that you will retain for a long term. Secondly, the more things you try, the higher the chances are that you will find a domain that you're really passionate about. And in this case, if you work in this domain, your work will be really interesting and enjoyable for you. And the last point, if you're currently looking for a job, doing a side project is a great way to strengthen your CV. And once you went through all the stages of the project development with its ups and downs, for sure you will have lots of things to talk about during the interview. So let's start with the first project idea, and this is a panorama. I think you all saw, or maybe even used, the panorama mode of the application, of the camera application on your phone. And today we will see how panoramas are made and how you can implement one using OpenCV. So what is panorama? We are given several images that depict the same scene, or at least some overlapping elements of the same scene, and we want to compose them, we want to collate them to create one big panoramic image. I think if you try to do that in your head, you will start by looking for correspondences between the images. And on a very high level, that is what we are going to do, but with the OpenCV library. More precisely, firstly, we are going to look for special key points that are located in the regions specific to this image. For example, the key points can be located on some corners or edges that are drawn on the image, or maybe in the places with a high texture variation or different brightness variations. These key points and their neighborhoods will be specific to this image, and that's why we would like to work with them. But if we will just analyze the colors, the pixels around these key points, and try to compare them between the images, it won't work, because the same object on different images might be slightly rotated or stretched or otherwise distorted, or maybe there might be some brightness variations, so you can't compare directly the values of colors. But in this case, you can use feature descriptors that are special vectors that are calculated based on the pixel values around the key points that we found. And the great thing about them is that they are invariant to the geometric transformations, for example, to the rotations and brightness variations. OpenCV library has a so-called SIFT algorithm inside it that can help you to find these key points and these descriptors. So we found the descriptors on every image, and then we will try to match them between the images, because we can do that as the same objects on different images will have the same descriptors. Here I visualized only part of the matches, so if there are really overlapping regions, overlapping parts of the scene of the image, there will be lots of matches. And once we found these matches, once again, using the OpenCV library, we can find a geometric transformation we need to apply to the image. More precisely, we want to find the way we want to modify the image on the left so it could be seamlessly collated to the image on the right. And this is how image will look like after this transformation. We can see that it was slightly rotated, stretched by a lot, and perspective of the image has really changed. But will it work for the panorama? And yes, we can see that now two images can be perfectly collated together. The point of view is the same, and now we have one bigger image. We can continue in the same manner and add more and more images to create final panorama. So let's briefly review one more time the framework that I presented. Firstly, we found and extracted the feature descriptors from the image. Then we tried and matched the descriptors between two images. Then, based on that, we found the transformation. And finally, we aligned our images to get final panorama. This framework is a pretty common one. It works not only for images, it works as well for the 3D scans. Also, this approach is used in many different fields, for example, in robotics, in medical imaging, and also in the 3D reconstruction. You can see an example of that on my slide, where we had two partial views of the building, and then using this algorithm, we align these 3D scans to get one perfectly reconstructed 3D object. The SIFT algorithm that I mentioned, that is part of the OpenCV library, is really the most basic one. It doesn't have any neural network inside it. So if you want to go further and enhance your project, you may want to experiment with different more advanced feature descriptors. For example, there is one that is called superglue that takes advantage of convolutional neural networks and graph neural networks. There are even more complex ones that are based on the transformer architectures. And the second idea for the improvement is to implement the image post-processing. For example, you can trim empty areas of the panorama, adjust lighting, or refine the pivot image selection. Now let's move to the second idea for the project that you can do using the OpenCV library. And we are going to talk about face detection. But firstly, let me introduce several interesting features of OpenCV. It has many different object detectors, and they for sure have some advantages. First of all, you don't need GPU. So that means if your computer, if your laptop doesn't have a graphical card, it's not a blocker to do this project. You can still run this library. Secondly, it's really easy to install and to use this object detection function. For example, if you are using Python, you just need to pip install the library itself and only to download one object or one file per object category. And you can go ahead and run the algorithm. Another cool thing is that it works in real time. So you can parse the video stream from the web camera of your laptop and process these images directly in real time. There are many different object detectors that are implemented inside this library, but today we will specifically talk about face, eyes, and smile detections. I believe that's a great foundation for your project. And when I say foundation, I mean it. So if you try to run the smile checking algorithm just out of the box, it won't work very well. On my slide, I showed the results of the smile checking with the red rectangle, and we can see that maybe it's better than random, but it's not stable at all, and this is not the quality of the project that we are looking for. But we can try and apply some pre-processing to improve the results. For example, the detector functions, they take some parameters and we can try and tune the parameters based on our data. Then we can convert the image to the grayscale and apply some image normalization. And lastly, as you may notice, the face detection that is drawn with the green bounding box, initially, just out of the box, it was really stable. So it means that we can use this information and cut the crop around the face and only pass this part of the image to the smile detector, so we won't give it another unnecessary information of the background that in any case doesn't have any smiles. Let's compare the results. We can see that once we implemented some pre-processing, the smile tracking became really stable. So let's put everything together. We have face tracking, smile tracking, and eyes tracking. Let's try and implement some interactive mask using this approach. So here we are tracking the bounding box of the face. Then we use it to find the smile and find the eyes. And once the smile is detected, we add the sunglasses that are located in the regions that are defined by the bounding box for the eyes. You can also implement some face blurring, or maybe you can also blur anything but your face if you don't want to show the background, for example. So let's sum up and see what other cool things can you implement using the face tracking from the OpenCV library. Firstly, as I already mentioned, you can implement different interactive face masks, as there are also, I think, some hands detectors in the images. You can implement the masks that are based on different hands gestures. Secondly, you can implement some face-based authentication, since you know how to crop the face, how to detect the face region with the OpenCV library, and it also provides some functionality to extract the features that are specific to your face. You can you can train the algorithm to distinguish between your face and face of some other people. In addition to this, you can easily implement presence tracker or smile counter. And another interesting idea is to implement a best photo selector. So for example, if you have many photos and you want to filter only the ones where your eyes are opened, you can, in this case, use the algorithm that I showed that detects the eyes on the photos. Also, you can detect the smile and only select photos with a smile, or maybe only select some images where you are the only person on them. And the last project idea is to implement an emotion tracker or emotion recognition algorithm, but in this case, you can use OpenCV library only as a pre-processing step, and you may need another external library for the face, landmarks predictions, and emotions detections. I hope my presentation was interesting and that you learned something new. If you have any questions, I will be happy to answer them.
Thank you for this presentation. It was really interesting to have you walk us through, to show how we can start simple and it's accessible. It seems very accessible when you present it.
Cool, I'm very happy.
Is there any question?
Thanks for your talk. I was wondering, do you have an explanation for why out of the box the face detection works, but not the smile or eyes detection?
I think because it's more complicated, for example, face is pretty big compared to the smile, and I think there are much less like variety in the general form of the face. But for the smile, there might be different form of lips, of the lips color, and that makes it more complicated because the algorithms that are in this library, they don't use any neural networks, so they use really the traditional computer vision, and it's fast and it's like relatively easy as algorithms, but they are very sensitive to the input data.
Any other question?
How much data do you need to train such like face detection, for example, or smile detection? And another question, do you work with videos directly, or you split it on frames? Thank you.
So thank you for your two-part question. So firstly, I didn't explicitly suggest to train this detector, but I think they used several thousand pictures. But for example, if you want just to implement the face-based authentication on your face, in this case, you really need to train it, so it would recognize specifically your face. In this case, you need several, I think, maybe 200 pictures at all, but not 200 pictures of your face. Of your face, around 50, that would be enough. And yes, the second part of your question was about if I work with images. Here, yes, and for example, during my previous work as well, we worked in the per frame manner. It's, I think, the most basic and the easiest way to apply the algorithms. Then you can add different like heuristics to make the things smoother between the frames. But the idea is, yes, to split the video into separate frames and to process every frame separately. I think in my presentation I also added some noise reductions between the bounding boxes. For example, if you detected a bounding box on one frame, the bounding box on the next frame can be in some kind binded to the previous values, so it will be more stable between the frames.
Thanks a lot for the talk. It was really interesting. Just curious, in your dental crowns work, do you use a lot like OpenCV traditional methods, or are you now switching more to like maybe neural networks or whatsoever?
There are many different projects. Personally, I work mostly with machine learning, complicated machine learning pipelines, because I work with the high quality scans of like high quality 3D dental images, and specifically we work with the point clouds, and then we use big architectures, for example, of variational autoencoders, where there are many small transformers inside to get the best results. And I think in many cases for such complicated detections or like for any complicated things, especially if you want good and stable performance, you will use now machine learning approaches. But to start, I think it's better to go with the traditional computer vision ones.
Thank you. Do we have any last question? Yes, sir.
So is it possible to integrate AI tools or AI pipelines for detection or vital surveillance?
Can you repeat the last part of your question, please?
Is it possible to integrate AI tools like Claude or anything to have better video surveillance images? I don't know how to say in English.
I think it depends. For example, as I think I didn't work personally with the Claude, but I thought that it's a text model. I don't know if it's an image model, so it really depends on what the model was training on. Basically, you can, if this tool allows this, you can integrate it anywhere and analyze images.
Thank you, and thank you very much, Irina.
Thank you.